Welcome to lesson 8.3. So in this lesson, we're going to be multiplying powers with the same base. Note, same base. This rule that I'm going to show you only works if you have the same base. So the rule tells us that if we have a to the m times a to the n, and again, notice how we're multiplying two numbers that have the same base but different powers, or they could have the same power as well. The rule tells us that we add the powers and we have one single base. That's our rule. Again, in class we'll talk about why, how. I'll show you some examples. And again, when in doubt, write it out is going to be our mantra for this unit. So using our rule now, we have 7 to the third times 7 squared. So our rule tells us that if we have the same base, we can add our powers. So since we have the same base of 7, we can take that 3 plus 2, and we get 7 to the 5th, okay? With our second example here, we have 6 to the 8th times 6 to the negative 8th. So our rule tells us, that we can, again, add those. And since we've got a negative, we end up getting 6 to the 0. And what does anything to the 0 power equal? That equals 1. All right, so just something to consider there. And we'll talk about multiple ways of looking at that exact problem here in class as well. So here in example A, we have 4x to the 6th times 5x to the negative 4th. So what I'm going to do first is I'm going to rearrange this, because remember, we can multiply in any order as long as we are multiplying everything that's given here. So we've got 4 times 5 times x to the 6th times x to the negative 4th power. So now that we have that rearranged a little bit, we can look and see here how we know that 4 times 5 is 20. And then using our multiplicative powers rule that we just learned, we can add our exponents of 6 and negative 4, and we get x squared there. So that is taking that 4x to the 6th times 5x to the negative 4 and simplifying it down so that we only see each base appearing once. In our second example, we've got 2q times 3p to the 3rd and times 4q to the 4th. So again, I like to rearrange them. I'm going to put all of my coefficients in front here. So 2 times 3 times 4. And then I'm going to multiply times q, which is q to the 1st. Remember, that's understood to be a 1 there. We don't often write that. And then q to the 4th, and then p to the 3rd. That rearranging helps me see what bases I can combine. So now that I've got that, I can take 2 times 3 times 4. Again, 2 times 3 is 6. 6 times 4 is 24. Okay? And then q to the 1st times q to the 4th, adding those exponents gives us q to the 5th. And then p to the 3rd doesn't have any like bases to multiply, so we're just left with p to the 3rd there. So that is simplified down so that each base only appears once. And here, real quick, we can see in that second example that notice how I have p to the 3rd and q to the 5th. Order doesn't really matter here. Mathematicians like to go in alphabetical order. It's not necessarily like a big deal if they're out of order, but it's just something when we simplify, we like to try and keep those letters in alphabetical order just to kind of organize ourselves. So now we're going to apply this to some scientific notation. So just like before, we can multiply in any order here. So if you see here, we've got 3 times 10 to the negative 3rd times 7 times 10 to the negative 5th. So what I'm going to do is I'm going to multiply, and again, I'm going to rearrange that a little bit so that I've got 3 times 7 times 10 to the negative 3rd times 10 to the negative 5th. This will help you see, hopefully, a little bit how we can reorganize this. We didn't need to grab a calculator to do this multiplication because we all can multiply 3 times 7 and get 21. And then using our new rule that we just learned, we can add those powers together to give us that -8. Now, technically, we're not in proper scientific notation, so we should move our decimal place over 1, so we only have one number in front of that decimal place in scientific notation. And then we have to add another power there, and that gives us -7. And again, we'll be doing a lot more examples of things like this in class where we can talk about it, and you can kind of ask some questions about why I'm doing certain things. And our final example here, this is an example of what we call the factor label method too. So you might have heard us talk about that in class a little bit. And this is where we're converting things and using this, sometimes you'll see it, dimensional analysis. So the speed of light is 3 times 10 to the 8th power. And notice how our units are meters per second, okay? And we want to then find the speed of light in kilometers per hour. Okay, so again, matching up our units a little bit, we want to be real careful here. So we know now that there is 1 times 10 to the -3rd kilometers in 1 meter, right? So if I put that in the numerator here, okay, remember, that's our kilometers. And then I have the 1 meter here. Notice how my units are going to cancel out, and I'll be left with the kilometers. And then again, we know that there's 3.6 times 10 to the 3rd seconds, so in 1 hour. So if I put that 3.6 times 10 to the 3rd, and that is seconds in 1 hour, okay, notice how my seconds are going to be canceled out. And now I'm left with that kilometers per hour. So what I'm doing here is I'm just multiplying these 3 numbers together. But again, you know, setting it up, I can see why I have to multiply and maybe not divide as we would in some of our other factor label problems that we've done. So now that we have this problem set up, we can see where we're going to multiply and what we're going to multiply together. And I'm going to rearrange this and have 3 times 1. And again, I'm not going to write that 1 because we all know what happens there. So it's 3 times 3.6 times 10 to the 8th times 10 to the -3rd times 10 to the +3rd. So again, using our rules, we can start to see where maybe our powers are going to cancel out a little bit here, okay? And see how 10 to the -3rd and 10 to the 3rd, that's going to become 10 to the 0. So this is kind of going to cancel each other out. And we're left with 3 times 3.6, which is going to be 10.8 times 10 to the 8th. And our units are going to be that kilometers per hour, okay? And then again, we're not in proper scientific notation, so I need to here. So I need to move that decimal place over 1, so it's 1.08 times 10 to the 9th kilometers per hour.